Alright, it's been a little while since I've made a video like this, where I'm going to be working on my Go Bridge project, which takes Golang structs and generates TypeScript validators. And the goal of the project is to start with those TypeScript validators, which I'm using Valibot for, but to also then generate any kind of TypeScript type or a Zod validator, or actually it doesn't have to be limited to TypeScript. It could take Go code and generate anything at once, which would be really cool. I'm starting with those validators because it's something quite useful to me when I make requests to a Golang server, and just on the JavaScript side, just to be safe, I want to validate based on the structs from the backend. So there's a little bit of code generation. It's quite a fun project. It's been a little while since I've worked on this. I've just been fixing around a couple of merges from some kind of strange things. I actually have had two different Git repos that kind of got messed up, so I had to add a different remote and play around with that. But let's start off by seeing what we can run as a test, because I'm pretty sure a lot of them are broken. So test nested deps, let's start with that. Test nested deps. Okay, let's just run that. Deps. It gives us this. Test nested dep goes to Golang 2 here. And it just kind of claims that world is any, which is wrong. Yeah, I mean, can't argue with that. It is definitely wrong. Nested dependencies has nested.nested struct, which, you know, looks really simple. So it seems like I've broken something fairly fundamental with this merge. Okay, let's have a look at where we stand. There is this bit that you guys haven't seen, but I'll get to that in a minute. Let's just try and solve this one. So we start by going into here. We parse the struct field. We get to here. It's a selector expression ref, so it should really go into here. To refactor inside a function, yes, we'll have to do that. We do grab the import. Oh, see, I think I've seen this issue actually. Let's just bring in fmt, print line the full path, which I think is wrong. I remember very vaguely kind of playing around with this. Yeah, slash go dash bridge slash test slash. Yeah, that's wrong, because when we consume that directory, we're not really going anywhere, are we? We're going, yeah, it's going to try and read it. It's just going to read nothing, where it should just go into test. And why is it doing that? It's doing that because, well, because I've organized my code terribly in this function. But let's have a look at what the stripped value is. I would love a debugger right now, but I don't really have one set up, so that's kind of annoying. Printf stripped value. Stripped value is correct, and let's also do import package name, which is import package name, which takes the base of that, and the base is import package name nested slash go bridge. Yeah, nested slash go bridge. Interesting. Find that kind of odd, right? The base, I think, should be this. what does filepath.base do? Base returns the last element of the path. Trailing path separators are removed before extracting the last element. If the path is empty, returns dot. The path consists entirely separators, returns empty. Okay. So we go nested / go bridge. Oh wait, no, that's a new line. Whoops, not even sure. Oh, that's being logged down there. Oops, well that was confusing. Nested, yeah, that's right. If import package, then we break dependency import full path. Okay. Let's print full path. Let's also go dependency import. Oh, what's this? Print f. Yeah. The full path looks wrong, which makes me think that it goes into here, and this is just incorrect. And the dep is nested. Give me 1 sec. What is the? Is this the only thing? So GitHub. What about Go mod? What do you say? Go bridge. So I mean, we should remove that from the paths, from what I remember. Okay. If import package name, which is nested, is equal to the package name dot name. If we are in the same, no, what's? I'm not even sure what you refer to actually. Oh, the package name is nested. Oh, it's like okay. It's like we're searching through it. Yeah, we're searching through all the imports. Once we hit one, we do this. But we are stripping maybe too little. Should it be +2? The length of the p.project path. Okay, let's just do that as well. Just sanity check, make sure. Yeah, audio's all good. p.project path. I think this might project path. Is that correct? I don't think that's correct. Oh, it's not correct. GitHub.com. Okay. Oh, and look at all these. Yeah. Oh, and some of them are extra wrong. What's GoMod say? Wow, okay. That's interesting. Okay. Go bridge to be replaced by this. Okay. And we also have, it was John Costa .tech. Oh. No, John Costa .tech. Oh my god, come on. What are you doing? Text /go /go dash. Can't type. And the escape characters. And we should be all good. Okay. Alright, that all works. How many others are dying? Test step struct. Oh, I should also let's commit that. Fix tests using correct paths. And test step structs. Test step structs is in parse file. That's really early on as well. Structs. Okay, this is for test 6. Okay, it's like time.time. So it's when like we don't really know what to do. And it looks like it's attempted to go to get package path. Okay, so it's the same kind of error. Get package path. Get package path has tried too much. Right, so because it's going to go through the imports. V is idle path.value. Oh, and it's assuming too much, right? It's assuming way too much. If I just go and print line V at this point, we'll see that it's just assuming that it's every import is. Yeah. So I guess what we have to do is a check, right, that it includes or that it starts with. If strings.start contains p.projectPath, the string and the substring, so it's going to be v. If v contains project path, or if it doesn't, we continue. If we ever come into here, get package path, dependency package path. We should return something else. Maybe. I mean, I have another kind of idea. So what happens here actually? If it isn't, oh, I don't like that. Yeah, it's just terrible code. This parse dependency field is just horrible now. Okay, well, what happens now? It still crashes because it goes into parse dependency field for 192. Yeah, no, it goes too far. It goes too far. We don't even care about this, do we? Like we're kind of assuming something else. When would this line ever be run? Struct name equals order struct dot package. Oh, when it's the same, when it's in the same package, right? But for it to be in the same package, the name would have to not exist. So if we import time.time and our imports have to include a string that exactly matches the before of this. This doesn't take into account renaming, which we will probably take a look at in future versions, but not yet. So that's how we do this. But now the return for this is just going to be more complicated. Is there a return on an instruct field? There is. Then this must be the external dependency. What the hell? What am I doing here? I could just I could do this entire check earlier, I think. Like without doing this. For sure. Yeah, this is not particularly great code. You know that there's memes where you start just mouthing off about the code and it's you who wrote it. Yeah. Okay. Is local dependency? No. I'm not even sure what to call it. Is local dependency. Is local dependency. This is actually going to take the imports, which is ast.import_spec, imports, which is ast.import_spec, and the base. What would you when you do something like time.time, this part here, module name. I'm not sure. I'm going to call it module name. Returns a boolean. And then we're going to use some of the strings dot. Well, actually, we can do return the length of module name is smaller than or equal to, smaller than or equal to, no, it can be just smaller than. Then we can make it a parser function just because we need some of the parser data. And p.project path. Yeah, actually, let's do that in an if statement. It's a bit tighter. If it's small, then we return false. It can't possibly be. Otherwise, we go return strings dot module name between 0 and the length of p.project path is exactly equal to p.project path. Yes, I think so. Okay, and we go up here if p.is local dependency for the structs dot file.import and the package name.name. If it is not a local dependency, then we actually I've jumped too far. Then we want to do what this bit of the code did down here. What is identifier there? Oh yeah, we should still do this actually. And then down there we can assert that it exists. Okay. And what is exp ident package name? Identifier. Wait, did I not? Wait. Oh, I'm actually stupid or something. That already does the thing there. The package name is package name.name. And then it does the expression of selection.name. Oh, I'm a bit silly. Like what? I don't know what I did there. But should always exist at this point. That's so ugly, isn't it? This function. So ugly. Okay. Is that a pass? That's a pass. Nice. What else we got? Did we break a bunch of stuff? Test nested depths. Yeah, we did. Test nested depths. Oh, it's just going straight to any. Okay. Unused parameter. Is local dependency. Wait, what's module name again? Yep. Oh, wait. No, yeah, this is kind of wrong, isn't it? We need to do a check for them. If one of them exists. Okay, so we need to check that. Oh, wait, is this just way easier than I think it is? So we just go for underscore v imports. Actually, just imp. That doesn't sound right. I in the range of imports if I dot name local package name including dot. Well, I'm not sure about this one actually. Is exactly equal to module name return false. Otherwise, we return true. Wait, no. This is all silly. This is all very silly. When we get to here, we actually already know that it's not going to be the same package dependent. Cool. We know it's not going to be a same package dependent. So, okay, we grab the package name. What do we know here? We know that either it's going to be something like nested dot something or something like time dot something. And we want to know which one. So we want to know basically if there exists a thing whose base is this. And if it is, then we want to know if it is also a local dependency. Yeah. Okay, so what we want to do here is go. We do want to go through that. Actually, let's go package import base file path.base at i.name. And let's just print. I'll show import base. There we go. Let's just return false. This should just break the test, but oh, a segfault. That's fun. 167 here. I.name. Can I be undefined? Oh, is this null pointer? Did I get null pointered? No, did I get null pointered actually? Dot name. Dot name is nil. What? Printf plus, let's do this, imports. For that zeroth item doc, the name. How is the name nil? That can't be right, surely. Surely that cannot be right. What? Guys, I'm confused. Let's print there. Okay, well, same thing. At least there's not anything kind of really strange going on. Test nested depths. This is test 2. Yeah, it's there. It's there, bro. It's actually there. If I do go build, what happens? Yeah, it works. And I mean, does it check these files? I mean, it parses them fine, so... That's odd. That's really, really odd. Oh, is it a dot path? Is this... dot path. Why is there a dot name then? Oh, I bet then... Okay, I know why. I know it's because you can rename things. I reckon it's that. Yeah, there we go. Okay. Little skill issue on my side, I guess. Value. Let's just do a function called... is there a strip? No. Strip string s string returns a string. Yeah, this is just going to be a super dumb function that just does this and this. Strip string of this. There we are. Nested. Good. Now, if the import base is equal to the module name, then here's where we do our actual checks. Here we can panic. Unreachable. It should be unreachable for a... you can parse a file that's semantically incorrect, or at least fails type check and stuff like that. So maybe the unreachable isn't the best error handling. We should kind of we should float things up. I'll leave it for now. Potentially float an error. This can only be triggered by a Go file that would fail. Was it semantic check? No, it's not semantic check. Semantically, it's fine, but it's like a. It's not really a type check. It's a dependency check. Dependency check. Okay. And if it is, we have found the one. And I don't like being this nested, to be fair. But we'll continue. We found the one. And we can see if it does start with that. So if the length of the stripped value, strip value there, if the length of the stripped value is less than p.project path, we return false. So it can't possibly be this. Otherwise, we return whether it contains our string, or actually where, yeah, we've done this before, a stripped value between 0 and the length of p.project path is equal to p.project path. Okay. all good. All good there. Okay, well, we fixed one. We fixed one, which I'm happy with. So I'm going to just commit that. Delete the binary. I need to just go bridge. Go bridge is added. Why are you asking me? Oh no. Did it make it onto? Did the binary make it onto there? Go dash bridge. Git rm go dash bridge. Yeah. Let's get rid of you. Sure. Deleting binary. No, actually, we'll force push the whatever commit did that. Okay, so here we go. Fix. Checking if a package is from a local dependency or not. Okay. And let's just do that little quick chore. Git log. What is it? I'm trying to go dash bridge. Git. How do I find git find which committed file? Git log path, right? Yeah, okay. Merging. Work in progress. It's this one then. This one. Oh yeah, there it is. I can remove that. Oh, I need to. My config, if I have the GPG signing on, doesn't let me do that. This really cool feature of LazyGit, which is just pressing delete on a file and just very quickly kind of getting inundated by stuff like this, but sure. Oh no, actually I don't want to do that. I was trying to be clever, but I'd have to fix kind of a lot of annoying stuff. Never mind, I will not be clever then. And I will just git rm go bridge. Still in history, but oh yeah, it's still in history. Whatever. Let's move. Okay, what else do we have broken? So good. Test 5. Test nested dependencies. I love how we have test nested deps and test nested dependencies. I guess because I was running out of names. Dependency. So I think this is actually fine, and I just messed up the file by like a merge earlier. So D is good, B isn't good. B needs hello string. And what else is not good? Is that it? Alright, poke. I think sure. Fixing test snapshot. Next thing is this actual hard part, which is test 8. Test 8 is new. This is all new code. And it's kind of the last chunk until GoBridge becomes useful, I think. Where we have nested.b that goes into B. And currently I'm processing B, which is good, and I'm pressing A, which is super secret string for embedded deps. That actually does point to the right thing, And let's have a look at that code. So we can kind of start to see where this is. When we parse a struct field, we do this switch on the field type, which is the right side. And if it's a selecting argument, we parse dependency field name. Oh, parse struct field type. Parse struct field type is used by this parse struct field. Parse struct field is used by parse struct. So it's a bit more direct. So this one checks if it's embedded or not, basically. That's what it used to do. It checks, are you embedded or not? If not, then we're going to go and just parse something else, which is down here. So which is, yeah, there you go, see? We should probably name is embedded field, which is whether the length of field dot names is equal to 0. This just makes the code a little bit nicer. Otherwise we parse it normally. If it's just an identiness of the same package, dependent structs go here. Do they though? I don't think they do. So that's kind of interesting. I think they go here. But we'll deal with that later, one thing at a time. It's kind of fun, kind of weird how chaotic this code base became pretty quickly. Like, it's really well tested. Like, the tests are great, but it's messy. It's quite messy. In some senses quite clear. Okay, but the kind of thing we're doing here is we are parsing the dependency field and then adding this embedded depth as the field name, because it doesn't actually have a field name, right? What do we add there? And the answer is, I am actually not sure. What do we add there? Because it's could we spread a? No, we can't spread a. We could, yeah. No, we have to do this. I was trying to think of like clever ways to do this on the backend side, which is when we actually generate the code. There's plenty of things you can do there. Let's read this comment I left to myself like a month ago. When we are processing embedded struct fields, two things can happen. It's embedded from a struct in the same package, at which point we can grab its fields very easily. Yeah. Two, they are dependency structs, which then are added as a basic struct field and the dependency resolved later on. For approach 2, we need to do some post-processing to get the struct fields in the correct position. This creates two approaches for the same thing, which is not ideal. Oh my god. I actually think we could move the embedded struct over to the backend, but I'm not sure yet. Until then, we'll keep both approaches. Yes, so we have like a processing queue, and then before, to get like the dependency fields, we do them straight away. Like we add them to this queue here, whereas we do some post-processing here. So the two are not like super well defined. So this is kind of, yeah, the same thing almost twice. But let's see. It's going to keep that name. What is it meant to do? Oh yeah, I never finished this code. Yeah, that's why it doesn't work. Here. Okay, so it reaches here. So it goes through each field in each struct. If the field.name is not equal to that, so it early exits most of the time, it checks that you're a basic struct field, the embedded dependency struct. For the process struct, if the process struct.name is not equal to the type, we continue in this. I'm not even sure what that means, to be honest. What this bit of code does. We're matching, yeah, basically we're matching, we were hoping to do something here, I'm pretty sure. We're matching the name of some process fields with the type. And we should get a match here, right? Match, yeah, match works. So we do have that processed struct. And what we're going to do is we're going to, I'm not sure how Go deals with this, but I want to do s.fields equals to append something. I want to append the fields that we found, which is going to be the process struct dot fields. Is that it? So fields. Not quite, I guess. Let's just do another one, another range over this. Or actually, yeah, no, it's fine. We can append, and it will continue. It will go here. This can be a lot more idiomatic. This is kind of not amazing at the moment. Print line s.fields. Let's just see. So s.fields contains, oh, is it the name? The name is still a bit funny, actually. Wait, what did A have? It had, okay. Let's do normal field string. Normal field string, great. And this one, and the name it should have. Oh wait, it should go into the, yeah, it should go into there. PS dot, okay, plus struct dot fields 0 dot basic struct field dot name, or actually dot name, and I think this should give me hello from B. Yeah, nice. So then when we're spreading the fields, we actually want to remove this one. So we're mutating S as we go, and this, I mean, this is terrible to mutate S whilst in the loop. I mean, sure. Let's continue. We could, yeah, let's go new fields or processed fields. Which is equal to make process.fields an array of struct fields. Is it struct field 0? Or do I have to do this? Yeah, that's it. Process fields dot equals, we're going to append the field right now. Otherwise, when we find one, which should only happen here, we're not going to append the original. We're going to do process fields equal append processed fields ps.fields, and then after we should be able to just say s.fields equals processed fields. Why not? Process struct, I can do that in line. S. What does S give me? Oh, that is a lot of goo. Because I need to run test embedded depths. Should be the very last thing here. Well, I mean, that looks fine. Looks fine. What was I complaining about? Oh no, this one is not fine actually. It has string normal field, and it has this one, but it didn't name hello, and it appended it. If I ever reach this, oh, I have to reach it, right? I'm just kind of confused why it's. Test, and just gonna do embedded the field.name. A little bit confused. Yeah, it's that thing, the big string that we're kind of marking them with. We're doing this. We're going name hello. Oh, it's not name that we want, to be fair. It's what is it that we want? Should they here be? Oh no, they can be so many things. They can be so many things right now. Test. Test basic. And that's gonna be, let's just do this dot wrap this like this. And test basic dot the type. Type is string. The name is the name hello. But really the name shouldn't quite be hello. It should be should it be just straight up B? No, I mean, I'm so confused right now. Actually, I think this all looks fine. All right, no, test basic versus struct. No. I'm doing something silly here. Hello. Yeah, no, I'm doing something silly. I think this is never running for what we want it to run. Test this to super blah blah blah. We go here. And now we're gonna go print line name. Let's do F. Understand. And then the type. I think we're just getting mixed up here, actually. Let's see what you do. We want to be in process struct A. Where am I? Yeah, process struct A. And the type is nested dash B. Wait, the name is what? Oh, A, there. Good. And we're going embedded dependency field. Shouldn't that run a few more times? Yeah, that should run like a few times. this is where a debugger would come in. So helpful right now, actually. Reached this. We have, right? I think we did this earlier. We reached this. Just from review. Actually, we'll keep you for now. Reached this, and with what though? With the we're going through each field of each process struct with what process struct? We should be with B. Yeah. That's all good. And then the fields of B are just string hello. So process fields, we append them all of whatever the matching process struct is. So I think that's all fine. What's that stuff? Oh, wait. This is in line defined, isn't it? It is. Wow. That is interesting. Yeah. Yeah, so it's like all copied. It's all copied into the loop. So we actually got to go, if we want to do this approach, we've got to do something a little more evil and just do this. Yeah, there we are. Kinda evil? Question mark? Yeah, I think for this we need to have like better queuing and stuff. So now it doesn't matter which one comes first, A or B, because normal field is there and the dependencies of B. Let's just hello world sure. Okay, good. That's all working. Let's just update. Let's just update this so it looks correct. Oh wait, no. That's not it. Parse files test. Which one is a failing test? Oops. Test embedded deps. Oh, wait, I was in the right place. I just never actually changed it. Nope. Wait. Hello? We're going to visual mode. Guys, am I? Oh, this is a hyperland thing, which I'm using right now. I can't go into block visual mode because NVim has not taken over the keyboard. Oh, that's not okay. That's okay. That's really weird. Okay, but it all works. It all works, I think. Beautiful. Feet. Nest. Embedded. Feet. Okay, just embedded. Nested dependencies. Now, I can add to this a test case that I'm pretty sure is going to make it fail. And that's the recursive case. When you have an anonymous, you have some sort of anonymous thing that doesn't quite work. Oh, actually, the other thing is that we no longer need B. Yeah, we could remove B. But that's a little bit more complicated because someone else might need B. So we'd have to do a little bit of checking there. But okay. For now, let's do. Well, I mean, I could just add my struct to be a struct of nested.b. And now this would for sure not love me very much. Yeah, see. Back on its thing. We actually need to get rid of this. Oh, I committed that code. That's not great. FMT. Let's get rid of you. Oh, we do need FMT just for those. It has to be, yeah, it has to be recursive. It has to be recursive. But maybe that's for another video. I feel like I've been here a little while. I'm just gonna make sure to add a comment to here. This works well if you don't have a more complex inline types, such as an anonymous struct or a map or some combination of either. Sure, adding comments for next time. All right, well, kind of happy with the progress we made today. We have this recursive case to deal with, and yeah, we'll just power on through. Thanks so much for watching, and I'll catch you in the next one.